For an RC circuit, the time constant tau is given by the formula tau equals R times C, where R is the resistance of the resistor in the circuit and C is the capacitance of the capacitor. In an RC circuit, charge builds up slowly and makes a graph that'll look like this. And the time constant is defined as the time required for the charge on the capacitors to reach 1 minus 1 over E of its final value. Now the 1 minus 1 over E as a decimal, we can find that on calculator here. It's 0.6321. If we turn that into a percent, we get approximately 63%. Now, 100% would be what we call Q max, which is the maximum amount of charge that can be on the capacitor. So 63% would be somewhere around here. And if we just trace that over and intersect it with the curve, this is an important point in the graph. The time that takes is known as the time constant. The time constant is measured in seconds, and how long the time constant takes depends on the resistance of the resistor and the capacitance of the capacitor. In RC circuit formulas that we looked at before, we saw that there was a constant K in the formulas. K is defined as 1 over the time constant. So if we want to rewrite the formulas with the time constant included, first let's recall what the original formula was for current in the resistor. I as a function of time was equal to I sub 0 e to the negative k times t. What we want to do now is replace the k with 1 over tau, and then rewrite the formula in this new form. It'll look like this. For discharging, we'll just have the same thing. For voltage across the resistor, VR as a function of time is equal to VO e to the negative t over tau. And for discharging, as we saw before, we would use the same formula. For a charge on the capacitor, the formula looks a little different. it'll look like that, because here we are building up the charge over time. But when we discharge, we'll have this. For voltage across the capacitor, we'll have that. And when discharging, we'll have this. Next, we'll try to apply these formulas to an RC circuit.